And we are going to talk about first the nitty-gritty about this course, and then we will slowly launch into the course content itself. I do understand that this is rather early for you, but if I can come early, you can come early too. There are only 154 participants as of now, and I think you've got a class of 300, so you should make it a point to join in time. Also, your attendance is marked by this software, and software is very mechanical. So if you are joined later than 8:32, it will not mark your presence. So my advice to you is please join on time. It's not too difficult. Okay, so okay, can you see the slide?
Yes, sir.
Okay, great. So we are going to talk about the introduction to the course, and then we will slowly launch into ARM architecture. Before that, this is course IT 209. I think its grading structure is 304, and that brings it to 4.5 or something. Of course, my name is Amit Bhatt. TAs are not yet announced, and I think we'll form a habit of working without TAs because I don't know when TAs will be assigned, when they will join. It may take at least a couple of weeks. So till then, we'll form a habit of working without TAs. I have uploaded 3 books on Google Classroom. I hope everyone has joined Google Classroom. If you are not joined, if you have not received any email, please let me know. I have put the first book, which we'll be using in the beginning of the course, is ARM Assembly Language by William Hall. That gives you an introduction to the assembly language programming. This book I have not uploaded, but you can easily get it on the net. This is a much detailed and much more in-depth book as compared to this. So in other words, ARM Assembly Language by William Hall is an easy book to read, whereas this one gives you much more technical information. For this particular course, if you are only interested in grades, I think this book should be sufficient. The second part of the book is Computer Organization and Design by Peterson and Hennessy, and Computer Architecture, a Quantitative Approach by Peterson and Hennessy. Now, okay, Ruchir, turn off your mic, please. These 2 books, Computer Organization and Computer Architecture, I've also uploaded. They are considered as the de facto standards. Excuse me, Ruchi, if you are listening, please turn off your mic. Now, it may be a little difficult to read and difficult to understand, but that does not take away the importance of these 2 books. So, and I'm going to introduce you to who the Peterson and Hennessy are in a very short while. But these 2 books, if you read them carefully, I mean, they will give you a whole lot of knowledge, much more than what I would be giving you in the lecture. If you are just interested in grades, then listening to my lecture is sufficient. If you want more knowledge, then, these two books are there. As I've been telling you right from the first lecture, that, I have got 40 hours of lecture. And 40 hours of lecture is not going to make you a master in this course. You will have to do a lot by yourself. And that depends on your inclination, how good you are. I've always seen that people who get by doing minimum amount of work, they never become successful. They just float through life. And then there are students, who always does more than what they are told. They always succeed in life. I don't really see that genius people, I've seen that genius people are not always successful in life because, some genius people are lazy. Whereas hardworking people always get successful in life. And I have seen this right from 2001, both in academia and in industry. So I cannot emphasize this fact more. So please read on your own. I will be mentioning many things here. And if you want to know more about it, you can always access the net, read up on it, and ask me questions. Do not form this bad habit of your colleagues and your seniors of studying at the last moment. See, in school exams, you had things which were very much up to you, like notes were there, and there were 500 unsolved problems and many other things which you can just refer to. And, on the last day, everything is there. But here, a lot of people have tried to read up on the last moment, and, you can get C grade or, below if you do that. If you're satisfied with that, I have no problem with it because, finally, it's your future. I don't get paid more or less based on, how much grade you get. As a person who is interested in developing or nurturing a young mind, I definitely do mind if you don't study or, if you just put up the study at the last moment. And that's what I call exam-oriented studying. Now, normally the grading policy in this kind of course is 25% midterm 1, 25% midterm 2, 10% lab, 10% quiz, and 30% final. This is the normal thing. In case of online semester, we have just one midterm and one final. Once again, this is tentative because we don't know what things are going to happen. So, but it would be something like this, 10% of lab might be lab plus attendance or something like that. Things would be clear before the first midterm. But, this is more or less going to be the grade distribution. It may be 5-10% here and there. This attendance will be taken on some days is again applicable for regular class if we start this semester. Otherwise, this particular course, attendance is measured automatically. Those who are in by 8:32 are measured as present. The rest of you are measured as or marked as not present. And also, if you are thinking of beating the system, that once you log in before 8:32 and if you log out by 8:35, it won't do because your attendance is not completely marked till you are there to the end of the course or till I leave the meeting. Okay. But that should not be the guiding force. Attendance, I mean, you may just log into your computer and go to sleep and beat the system there. Nobody can do anything about it. It's up to you. Okay. The course organization, you can go and read up this. I will put this lecture slide in Google Classroom. And then, you can take a look at it. I will tell you what to read because, now the editions keep on changing. What I have put is the latest edition. AAI stands for ARM architecture. Introduction to ARM Architecture or ARM Architecture Introduction. So this book is, you can read on your own. I mean, and I'm not going to take too much time because you have learned C language, and programming is something, teaching programming is not the purpose of this course. You should be able to learn on your own. Having said that, as I told you, there are certain marketable skills that you should have. And knowing ARM architecture and knowing ARM architecture programming is an important job-oriented skill. The companies like Samsung, Qualcomm, you name it, MediaTek, they're all in Bangalore. And what they do is they make mobile phone chips. And all mobile phone chips are based on ARM architecture. And they've got a very large testing division. And in testing division, you have to write test codes in ARM assembly language just to see that the processor which is coming, is it compliant to ARM architecture rules or not? We are going to talk more about this in this lecture a little later on, maybe in 15-20 minutes. So this is a very, very job-oriented skill, and I want you to spend some time on it. Okay. Then the question which comes around is, what is computer organization? And I showed you a diagram yesterday. And this definition puts it in a slightly different way. That it refers to a level of abstraction about the digital logic level, but below the operating system level. And in pictorially, we explained it last week, or we looked at it last week. Major components of processor and I/O system, memory, data path, and control. And do I need IT 209 course? I think we have talked enough about it in last lecture, and we will continue talking about it in future lectures. So probably I would let you make up your own mind whether you need IT 209 course or not. Okay, now this is a small clip I've taken from Imitation Game. And I believe most of you must have seen this movie. Very interesting movie. And the main character in that particular film was John von Neumann. And I really respect that person. He was one of the most brilliant person. Unfortunately, he committed suicide when he was 41. And if you have seen the movie, you know why he committed suicide. If you don't know, then he was called out to be a gay person or a homosexual person, and in UK at that particular time, homosexuality was a major crime, and homosexual people were chemically castrated. So he was very much afraid of it, and he ate an apple which was laced with cyanide and committed suicide. And I think that is one of the biggest tragedies of our time. Okay, so enough about von Neumann, but let us talk about the Imitation Game and the theme of the movie, because that's where the beginning of computer industry. Sorry, it was Alan Turing. It was my mistake, and someone rightly pointed out. I apologize. Turing, again, there is a Turing Prize, which is announced on this person's name. And, if you get Turing Prize, that means, you are a big name in computer science. Okay, the story is that Germans made a code encryption machine. And, they were sending that messages to their U-boats, or which are also known as submarines. And, basically they would be told that, there's a location of a merchant ship which is going from US to UK. At that particular time, US was not a part of allies. They were neutral, but, they were supplying logistics to UK. So they were supplying tanks, they were supplying ammunition. to UK or England. So this U-boats created a havoc by attacking them with torpedoes, and UK was almost on the verge of losing war. So they decided to make a code-breaking machine. And if you have seen this movie, you know the plot. For those guys who have not seen the movie, the story is that they wanted to make a code-breaking machine. So they hired some people, who had got puzzle-solving skills. They were from all walks of life. And the problem was that Germans were using a particular encryption key just for one day. And every night at 12 midnight, they would change the encryption key. So that means the code breakers had only one day to break the code. As they say that, if you want to crack a password, if the password is there static, you can work on it for 5 days, 10 days, 15 days using a good code breaking program. You can break the code and then, you can break the password and show the answer. But, and major banks on their website, they keep on changing their password every 6 hours, or some banks change it every 2 hours or 3 hours. So that gives you a very little window to break the code. So in other words, if you want to solve it by using brute force method, you have to have a very powerful, quote unquote, computer which can break that code. So they decided to make this machine. And lo and behold, it's a nice fairy tale story. And, in real life also ended as a fairy tale story, that they made a machine which would break that code. And of course, there were reasons that, they were able to decode every message, but, they were not acting on every one of them. Otherwise, Germans would know that their messages have been decoded. Okay, now here's the real story. So this is the Bletchley Park. That's where this particular movie or the set was there. If you have seen the movie, probably you recognize this building. And this is sort of a machine you must have seen in the background here. That, this is a more kind of a stylized photograph. And this is the actual machine. Now the Bletchley Park is in Buckinghamshire. And they rent this building nowadays for conferences. And when I was working at ARM, we had a meeting or our annual conference over here, research conference. And then, I had the good fortune to actually see this machine in real life. And that particular day was not as sunny and nice as that, it was rainy, there was slush on the ground. And, I had gone directly from India and landed there that morning, and that afternoon the conference was there. So my shoes were soaked with cold water. But, we went around the grounds, which is behind this building, and there were tin shacks. And in this tin shacks, all the major scientists were staying, including Turing. All the secretaries, all the clerical staff, all the scientists, they were supposed to stay on the premises and not go out. Very rarely they would be allowed to go out because, from outside the facade was just maintained like this. So nobody would know that what is going on inside. But, behind this building, they built this tin shacks where people were staying. Now, here they used relays. You know what a relay is, that, probably that relay is, one of the most common thing is used in electrical products. So MCB switch and other things, there's a relay. So there's a contact. And if the contact is broken, there is no power going through. When the contact is there, the power goes through. So it is a switch. And what is semiconductor that you are studying? Basics of electronics you must have studied. You study all these kind of complicated devices like, transistors, MOSFETs. Now, they're coming with carbon nanotubes, the latest of the thing. After all, they're looking for a good switch, which has got a good on level and good off level. So Whether you use a relay or you use CMOS transistor, the purpose is the same. The only thing is that, relay is much bulkier. And, as you can see here, things are not as compact. In fact, nowadays, if you want to build a computer like this, it would be smaller than a calculator. So that's how the switches have improved. So we have moved on from relays to real 2 nanometer or 5 nanometer technology in CMOS. Another thing, which would really interest you, that you must have heard about bugs, that there is a bug in my program. And, so any mistake which you have made is blamed on this, or is called or defined as a bug, that, there are few bugs in my program. You use the word, I want to debug it. Now the word, it's an interesting story why that word bug came through. Because, when they were using relays, small insects would get into between those two things. And, when the things close, because of the presence of the bug, it would not close properly. And then, the current would not flow. So basically, in other words, 0 will not be converted into 1. And then people would say, okay, there is somewhere a bug. And at that time, they were talking about real life bug. Now, any mistake is known as a bug. So that is sort of a thing probably you would like to know. So this was the beginning of the story of computers. Usually we think of war as a bad thing, and it is a bad thing because in Second World War, at least 8 to 9 million people died, including those unfortunate Jews who perished in Holocaust. Apart from that, many soldiers, very many civilians, and this numbers are just ballpark figure, because when you drop a bomb, people die, and that they disintegrate, and that sometimes the whole family dies. So exact figures are never known. These are all estimates, but a large number of people died. But on the other hand, it did a real good thing for advancement of science. So the first thing which was invented during this war was radar. So the communication system got a major boost. And all the later communication things which you are using nowadays, including your mobile phone, has its origin in the communication systems which were developed during Second World War, or it was a pioneer thing. The second important thing, and really important thing, was computers. That, this war showed the importance of using a computer or a computing system which can solve a problem. So Second World War was the one which gave real impetus to the computer field of computer architecture or field of computer science in general. Now comes the question. Now we are jumping from 1945, we are jumping into 2021. How many processors do you have in your house? Can you guess how many processors would you have? And obvious ones like, in the laptop, in the desktop, in the mobile phone are okay. But more than that, well, your mobile phone has average of 6 processors. There's an application processor, there's a DSP, that is digital signal processor for audio. There is a graphics processor, maybe Mali graphics processor for rendering video. Then there is something, which is a separate DSP, which is dedicated to camera, because, we all want our photographs to be sanitized, all the blemishes removed, and, our skin shade lightened by several shades. All those things requires AI and large amount of computing power. Plus, there is a baseband. So baseband processor is the one, which catches the signal. So your baseband thing, 800 megahertz, 3 gigahertz, and all these things for your Bluetooth, for your Wi-Fi, for your mobile tower, you require a baseband chip. Of course, Qualcomm is king in that. So, there are many processors in mobile phones. Tablets, I mean, there are more than 3. In fact, they are also close to 6 or above. Car, average 10 to 100. And, some of you might be a little taken aback that, how come you have so many processors in your car? Well, look at it. You have got ABS, right? ABS braking system. That is controlled by a processor. You have got fuel injection system that is controlled by a processor. In high-end cars, there are processors to measure tire pressure. There are processors which would trigger your airbag. And plus, there are many more. I mean, of course, you may ask a question that why there is not a single very powerful processor and why separate processors. And the reason for that is that, you don't want to have just one processor to fail and then whole system to fail. And now you are going to have features which are known as driver assisting feature. So that means, you would have additional cameras or additional guidance which is given to you by computers of your car, how to turn, when to turn, how to change the lanes, whether to change the lanes or not. So this is known as assisted driving, and this is just one step before completely automatic car. So cars have tremendous amount of processor. In fact, you would be surprised that automobile section is the biggest user of electronics. And, people who are working in writing software for automobile and, writing codecs for entertainment system and, writing software for keeping all these inputs from various microcontroller boards which are in there. And then, giving up an answer to either on the dash panel or, as a visual signal. I mean, those things are there. So 30% of the cost of the car is electronics, and it is continuously increasing. And with a battery operated car or electrical vehicle, that is going to be a major mode of employment. Now then, of course, there are processor and the set-top box for TV, and then there is a microwave oven and washer and dryer and dishwasher, coffee maker. I mean, you name it. In fact, you will be very hard pressed to find out an electronic device which does not have some kind of processor in it. Now, processor is not always like what you have in your mobile phone or your laptop. Now, probably this is a good time because, you would have heard the word embedded processor. And then, you would have heard general purpose processor. And, people say that embedded processor is the one which is in, say, washer, dryer and other things. And then there is general purpose processor, which is in your laptop. So what's the difference? Is there any technical difference between those two? The answer is actually there isn't. It is all about the perception. So let me give you the definition of an embedded processor. Now, embedded processor is one which is used in such a way that the end user does not know that he or she is dealing with a processor. Say, for example, a person operating a washing machine. A person may think that, I'm just pressing a button that, I want a gentle cycle or I want to wash jeans, so I want something rigorous. And there are various choices. As soon as you press a button, a signal goes to a microprocessor, which is kept, or a processor, which is kept inside, and a predetermined program, which is already written, it executes. So in embedded system, the user or the end user does not program it. It comes pre-packaged with all the programs it would need. And all the user may think is, oh, I'm just pressing a button. Or while you're driving a car, you don't even know that you are dealing with a processor. Just look at the dashboard and some light shines up, or some warning message comes up, or you get some information regarding the engine revolution and other things. So those things are great, and they are done totally, behind the curtains as far as the end user is concerned. So all those processors are known as embedded processor. So they are deep within the machine somewhere, and user doesn't know that he's dealing with a processor. Whereas on the other hand, in laptop, you all know that there is a processor because you write a program, you execute a program. And so basically, in other words, the end user is allowed to make changes or write programs and give directions to the processor. So that is known as general purpose processor. In fact, you would be surprised. Before we go to that, what would be the number of processors sold worldwide every year? It is more than 30 billion processors. And most of them are ARM processors. And 30 billion processors means, all the electronic items starting from the small toaster to the mobile phone, to the laptop, to the server, everything is included. So, in fact, there are more processors sold than there are people on this earth every year. Now, we have talked about processors so much. So, let us switch again back to the past. We jump from 1945 or 1942 to 2021. Now let's again go back to 1960s. You must have seen, you must not have seen this, but you must have seen this in pictures. This is the Apollo 11 landing. This was one of the, biggest event in human history, where human beings landed on a different planet or a subplanet or a satellite planet, and then looked at the Earth. And there is a very famous photograph that someone has taken it from the surface of the moon, and they showed the Earth rising in the sky. So this one, you can imagine Saturn V rocket. You should see it on YouTube. It was one of the biggest rockets till date. It took a man to the moon and back using a computer or a processor. As you can see here, this thing you see here was the processor. It was designed by MIT, the Massachusetts Institute of Technology, and it was built by Raytheon. It had a rudimentary real-time operating system. And we are going to talk about this word real-time operating system because, next year or next semester, you will be studying operating system. So, you will have a question. What's the difference between operating system and real-time operating system, and also a normal processor and a real-time processor? So keep that thought in your head. We'll talk about it either later in this class or in next class. Okay, so someone suggested, so this is officially what that particular processor had. The ROM was 36K of word or 37K of words of 16 bits. Its RAM was 2K. Clock speed 1 megahertz. 16,800 transistors were used. Of course, there were rudimentary transistors, measuring in terms of microns, tens of microns rather than, a nanometer, which we measure right now. Its volume was like almost 1 cubic feet. So, you can imagine the dabba. Weight was 70 pounds, and it was using 55 watts of power. Now imagine this kind of computer, if you give to someone today, they would say, I can't do anything with this. And in this memory, they also had operating system. So apart from all the calculations were done using 2K worth of memory. And what did this processor do? It was used in gyroscope. So it took a human being from Earth all the way to the moon and back. Isn't it impressive? In fact, this brings me to an interesting comparison. I met when I was a student, I met a person who was in the field of programming since early 70s, very old and knowledgeable gentleman. And he was telling me that, nowadays, you guys, when he said you guys means us students, at that time I was a student, you are real spoiled. You have got abundance of everything. Well, at that time, let me tell you what was considered as an abundance. In our computer, I had a Sun microsystem, which was considered as, top of the line server class processor or server class machine. The memory itself was few MBs. The hard drive was 512 MB. So it was less than what you have as RAM in your phone. If you give a phone to someone, with a half GB of RAM, that person would get up and say, oh, this phone is no good. But anyway, as compared to his experience of 1970s, this was like, abundance. He said that, the real programmer or real strength of programmer is known when there are lots of restrictions. And those restrictions come into embedded system. Your Bluetooth program occupies only 22 kilobytes of space, right? And people have worked on it for many months, if not years, to develop that program. Nowadays, you guys have 4 GB or 8 GB of RAM and so many TB of hard drive. And, your cache is also coming out in the range of 1 MB or so. So, you guys have never worried about the space. For you, memory is plentiful. So the programs which are written by young programmers today are kind of wasteful programs because there is abundance of memory. Memory is cheap. So, use a lot of it. Doesn't matter. Whereas if you are designing an embedded system, in space program, in embedded system, you are worried about each and every byte of memory which you use. And why is it important? It is important because everything is cost dependent. In this particular class, you will constantly hear two things. That just writing or just hacking a program, anyone can write a program, is not sufficient. You are supposed to run that program on some machine. Now that machine would have limitations. So like I have my mobile phone. What limitations does it have? There's a limitation of power. Why? Because it is running on a small battery. So max it can give, max power or peak power might be 2 watts or less than that. So can't take up more than that power. So that's a limitation. It may have plentiful of RAM. That means my phone has like 6 GB of RAM. But using too much memory takes up time because if there are too many IO operations, so if your processor constantly has to ask for some data from memory and back, it would take up time. So that means your program is not quick enough. And these are, so this is one of the reasons why you should study computer architecture very carefully, and of course, affiliated memory, which you are going to study in this particular course, is that you understand that, writing a program which has got a lot of IO, that is input and output. Of course, input and output is from memory. If there is too much of it, your program would run very slowly. So in fact, people work for ages to write algorithms which has got less amount of IO. And people write their programs very carefully so that there is not too much IO. If you are a game developer, if you are a high performance computing person, or even if you are say programmer for Amazon, you don't want your end user to click on something and then have to wait for like few seconds, because nowadays we have become so impatient that if our response is delayed by more than 4 or 5 seconds, we go somewhere else, or we get impatient, we start clicking the button, and sometimes we may freeze our device. So even if we have abundance of memory and abundance of computing power, still you should be very careful about the program that you write. It should not take up too much memory. It should not take up too much of computing time. So two things you'll remember in this course. One is, of course, as I told you, the power budget. Second thing, use as little memory as possible, because if you are designing a toaster or if you are designing a washing machine, everything counts. How much does a toaster cost? Maybe 1,000 rupees. And if your electronics is going to cost you 200 rupees, then the person who is purchasing your system would say, I don't want it, too expensive. No matter how good it is, it's not going to be viable for me. So in this particular course, you are going to know that economics is the king. That means you can do something, but if that task takes too much time, takes too much power, or takes too much resources, then it is no solution. You will have to look for something else. Okay, so this is the guidance computer block. So remember these things, ROM of 36K and RAM of 2K. And of course, they were all 16 bits. And now what do we have? This is Galaxy S20 or S21. It is a quad core processor, or sorry, they call it octa-core. But and we are going to, if we have time, we are going to talk about multi-core processors. So there is one processor, this is Cortex A77. So this is a trademark of ARM. Cortex A is ARM trademark. So there is A77, which is running at 2.84 gigahertz. There are 3 cores which are running at 2.42 gigahertz. And there are 4 Cortex A55, which is running at 1.8 gigahertz. And if you're in India, you don't get Qualcomm Snapdragon, you get Samsung Exynos chip, and which is with similar specs. And it is, look at the RAM. It is either 8 GB or 12 GB, and battery life is there, so on and so forth. In fact, if you had shown the specs to me around 10 years ago, I would have said, oh, this is a very high-end server, which might be running a whole company. And now, it is in one mobile phone. So, which means that your computing power is increasing way beyond expectation. And those of you who are, in love with terms like machine intelligence or artificial intelligence or machine learning or deep learning, let me tell you that AI, that is artificial intelligence or machine learning, became a reality only because of increase in computing power and reduction in price of computing power. I took a course in AI when I was a student in mid-90s. And at that time, we were thinking that, what is the point? I mean, who's going to use this? So this is only a theoretical subject, which might be useful for someone to do PhD in. They were also teaching us neural network now, which is the backbone of AI and machine learning. You thought that is all, theoretical subjects, and you can do PhD in it, and then that's it. No practical use. But as computing power becomes so cheap that nowadays, if you look at this Galaxy S20 Plus, its processor would not be costing more than $25 or $30. That is just the manufacturing cost. Of course, they add profit and everything later than that. But look at that. I mean, it's so cheap. So you can do all your things, starting from differentiating between cat and dog to medical diagnosis between like whether this tumor is a cancerous tumor or not, or how to play chess, or medical diagnosis, a whole lot of things. They can all be done with AI. So this is where we have come. This is where we were in 69. So you can imagine in 50, 60 years, we have done something which is truly amazing, and no other field in human history has gone through so many changes as a processor or a computer architecture or in general computing science. Now look at this. Apart from this, there is a relentless hunger for computing power. So the space shuttle, when it was designed, and space shuttle program is an old program, started in 2000 or late 90s. It had 500,000 lines of code. Boeing 787, what they call as a Dreamliner, and unfortunately it didn't succeed in the market. It had 3 to 5 million lines of code. And of course, it did not succeed because, the reason for it not being successful was not in coding, and there were other issues. And now top segment car is like, it has got almost 100 million lines of code. Codec itself is like, long thing, plus, there are various things. So now you can imagine there is a continuous hunger for power. So that means you are going to develop faster processor. To run those faster processors, you are going to develop programming techniques. You're going to be constantly aware of power restriction. If it's a mobile device, you would be worried about power usage. Even if it's not a power device, you would be worried about heating. You must have seen that, a lot of phones, if you use it, after a while, it starts getting heated up. And then, sometimes it gets so heated that, it becomes uncomfortable. So what do? We put a shield. And that is the stupidest thing that, we can do. Why? Because in laptop, if there are fans inside because, your processor gets heated up because, whenever you give power to, power to something, it generates heat, just like a light bulb. So when you dissipate power of 10 watts, but, within just few square microns, the heat density is too much. How do you get rid of that heat? Well, in my laptop, it's a big thing. So, it has got a big heat shield, which is made out of aluminum, a metal which can conduct. So it's kind of a shade put on top of this processor. Then, I've got fan. In desktop, I've got 3 fans. So if you're using a state-of-the-art, us gamers, if you are a real gamer, then, you'll require a big box with cooling fans. But in mobile phone, I'm using a processor which has got almost similar specs as the processor on my laptop. And this thing doesn't have any fan. So how does that work? Well, this one doesn't have a phone. This one doesn't have a fan inside. So the price you pay is that whatever the specs which I have given over here, like 2.84 gigahertz or 2.42 gigahertz, it can maintain the speed or frequency only for 2 minutes or 3 minutes. As soon as it starts getting heated up, the frequency, there is a break. So operating system would start slowing down your processor. So after running it for a few minutes, your phone, if you're playing a game, your processor speed would start coming down. It will not be running at peak speed. Whereas on the other hand, your laptop or better yet desktop would maintain the peak speed for much longer time because it has got better heat dissipation. If you are a Linux user, there are programs available which can tell you the heating of each core. And if you have got a quad-core processor in your laptop, you'll see the temperature is 90 degrees centigrade, 92 degrees centigrade. It can go all the way up to 125. So in other words, if you touch your processor with finger, in a computer which is already operating, you will burn your finger. It gets that hot. So this is about processors and architecture, how you should program, why you should be worried about architecture, all the things that we have known. And here, if you have any kind of doubts that where do we use processors in a car, you can read up on this, and it would tell you where are the processors. Okay, So now, we are coming into this historical view of architecture, so what we call as battle of architecture. This is a very interesting thing to know from historical perspective. And just one second. Okay. Let me first go here. There is, how many types of architectures are there? That means how many types of different varieties of processors do we have in the market? One which is very well known is like Intel processors, and they are known as x86 architectures. They are known as x86 architecture because when Intel started, their numbering system of processor was like, first one was 8086, then they came up with 286, then they came up with 386, then 486. So that's why people call it x86 architecture. Then there is ARM, which we are going to study extensively in this semester. A new entrant is RISC-V. And finally, there is MIPS, which, rest in peace, is now no longer useful, but it's a part of your textbook. So if you open Patterson and Hennessy, you'll see that that is the one which is taught. Now, I promised you that I'm going to talk about the authors of your textbook, which I have recommended. That is this one, Patterson and Hennessy. And the second book is also by Patterson and Hennessy. So who are this Patterson and Hennessy? Some of you may know them. Professor David Patterson is Google Distinguished Engineer, and he has got, I believe, ACM prize. I mean, you name it, and he has got that prize. He's a professor in Berkeley, and he's also on the board of RISC-V. So he is one of the top guys in computer architecture. I mean, people who have been working in the field of computer architecture for say 10, 20 years, they still read his book. The books which I have given you are read by practicing processor designers and architects. So my one advice to you is, if you find that particular book challenging to read, don't say the book was not good, because book is written by this stalwarts in this field. You can say I did not understand it. Don't say that the books were useless. Okay. So David Patterson, one, and second one is Hennessy. Hennessy is the professor, I think he's in Stanford, and he designed this MIPS architecture. So he has his own company and designed this MIPS architecture. And it was doing quite well. In fact, MIPS captured the market of set-top box, that set-top box were using MIPS architecture. And very recently, till maybe 5 years ago or 6 years ago, ARM beat MIPS and captured the market of set-top boxes also. So then MIPS got sold to, I don't know which one of the companies, well-known companies. MIPS architecture has been, that means that's rights of that architecture has been given to them. So again, now come back to the word. What is an architecture? Now, architecture is something which you will call a spec sheet, or things that a particular processor has to do to be called as having that particular type of architecture. So it is like, let's say it's like 4G or 5G. So 4G or 5G is not a device. 4G or 5G is a standard. So it has got list of specifications. So if your device, communication device, meets those standards, then you can say that this is a 5G device. But 5G by itself is just a set of specification. So Intel x86 architecture or ARM architecture is nothing but a set of specification. So it's an abstract concept. If you create an electronic product which meets those specification, then you say that, okay, this processor is ARM architecture compliant or Intel x86 architecture compliant. Now, Intel or x86 architecture, you would start wondering that, I've also seen AMD processors. Some of you may have seen that, AMD processors nowadays, Radeon, are becoming very, very high-powered ones. And, you can get laptops which are cheaper than Intel laptops. But, because of some kind of inner reason, we like to buy Intel processor. That, what kind of laptop you need? You say, okay, I need Intel laptop. Why? I don't know. Because, maybe Intel does good marketing. But then, AMD is also, Advanced Micro Devices is also a company which is making devices based on x86 architecture. So then you start wondering that how can two companies be doing it? Because, Intel is like very, very, it's a patented thing. So how come AMD is using it? The story is interesting. So I'll give you a little bit of history. IBM, you must have all heard of IBM. And IBM in last century, I mean, anytime between 70s to the year 2000, if you're working in IBM, it is like equivalent to working in Google. So right now, someone who's working in Google, would be very proud that I'm working for Google. At the same time, maybe 20 years ago, working in IBM was considered of the same stature. IBM's forte was designing mainframe computers. Now, that word has gotten out of fashion that, what is a mainframe computer? So basically, mainframe computer is something like what you call as a server. Nowadays, you must have seen that rack. We also have it in our university. And then there is a rack, and then, there are pizza box type of server units are pushed in. And, you can push 6 of them, 8 of them, 10 of them, and then, connect them, and, your computing power keeps on increasing. So mainframe was something like that. So IBM decided that, okay, people are getting interested in computing. So let's make a personal computer. And they were the one, IBM, who came up with the word PC. And PC stood for personal computer. So IBM said at that time that, okay, personal computer is a small computer. Our real business is mainframe. So let us outsource most of the things. So at the same time, when they decided to come up with personal computer, at that time, Intel, which till 1970s or 80s, was its main business was designing memory chips. Processors were coming from Japan. So at that time, Intel decided that, okay, we should make our own chips. So they made 8086. And then, IBM liked it. So IBM liked the concept of 8086 and then 286. Basically, they liked 286 because 8086 was a toy. So IBM said, okay, we will use your processor in our personal computer. And that was the first time because, IBM was, for IBM, everything was in-house. That, every product, every piece, every part which is used by IBM was manufactured by IBM. Nowadays, those things are gone. No one does that. Why? Because everyone has got mastery in developing one thing. So everyone is like sort of connecting pieces together, Lego pieces together. Even in designing SOC, companies like Qualcomm, they are good in making communication like baseband chips. That's where the CDMA thing. But they take processor from ARM. Okay, someone asked a question. I think the question was why 8086 or why number 8086? Good question. I don't know. There must be some internal thing. I have no idea because when I was working at ARM, they used to give internal names and external names. So internal names is like, there would be like a Sparrow for a small processor or Eagle for a large processor or Peacock from some different processor. And the marketing name, when they came into the market, they would be known as Cortex A77, Cortex A55 or something. Intel x86, I have no idea why they call it 8086, but it must be something internal. It's like, asking why Boeing 747 or 737, why do they use words like that? Of course, there must be some reason behind it. It must be a logical thing, but, they have not made it public, or at least I don't know. Okay. So at that time, IBM wanted to make anything. This is the first time they relaxed the rules and called up Intel that, you provide us the processor for our PC business. And Intel said, okay, yeah, sure, we will do it, because, Intel wanted business. But IBM people were shrewd people. They said, we don't want to depend on just one supplier, because, what if you just stop producing the processor? Our business would go down. So Intel talked to AMD and said, we will share our technology with AMD, and then AMD will also get the rights to produce this. And this arrangement worked till they produced 286, because AMD was also producing it and Intel was also producing it. Then Intel came up with 386, and that was a big success. And they didn't want to share things with AMD. And if you're interested, some guy from Harvard has written like the battle between Intel and AMD. I'll give you a reference of that paper. You can read it. But, that was the whole story behind it, that, Intel and AMD both are using x86. Now Intel is not sharing it with AMD, what it is doing, but, people are still doing it. Then came ARM. I think I should talk about ARM later, because ARM we are going to discuss extensively. But right now, just let me tell you that ARM was a company which was started in 1990s. It's not too far back. And without going into too much detail, they are the one that this company was started by 10 or 12 people. People like maybe slightly older than you. They just graduated out of Cambridge University. And they decided that, let's make a processor. And how difficult can it be? And they actually designed a processor, and they were able to market it. You will be surprised that, they were funded by Apple. And I will not give you the name of the product for which Apple wanted their processor. I will let you know in the next class when we go into it. But, ARM is a different thing. Then, it's the RISC-V. RISC-V is the reduced instruction set computer. We are going to talk what is RISC and CISC. Now it is a meaningless thing, but we'll talk about it in due course of time. So RISC-V is a completely open source thing. So if you look at the architectures, Intel x86 architecture is a completely patented thing, and no one else can make it. So that means I cannot make a processor by reverse engineering, what Intel has done, because, they will sue me. So only Intel can produce, and of course, AMD, only Intel can produce processors which are compliant to x86. If you and I make a processor which is compliant to Intel x86 architecture, they will sue us. ARM is a slightly better model that, ARM licenses it. So it has got license plus royalty thing. It would say, okay, if you pay us money, you can make a processor which is compliant to our architecture. And, you can sell it, but, you have to give us some money for every processor that you sell. RISC-V is something which came out maybe 4 or 5 years ago by the RISC-V organization, of which David Patterson is vice chairman, and Kurst Asanovich, a professor at Stanford, is the chairman, and is also, they have started a company called SiFive, SiFive, and they are actually in promoting, it's a commercial arm, whereas RISC-V is a non-profit organization, and they are giving out that architecture for free. That, you don't have to pay us any royalty, you don't have to pay us any licensing fees, but, this is open source. So it is just like Linux. whereas Intel 86 is like Windows, right? If you want to have comparisons. Okay. Now, this is the last slide which we will discuss. And, we will also discuss, something which I wanted to tell you, that IBM, I just told you that IBM started making PC. And, PC was a huge thing. But, it also tells you that how major companies misread the market. So IBM thought that, how many PCs are going to be sold? Who's going to buy PCs? PCs would be by some nerds who are sitting in their basement and trying to do something. No normal people would want to have a computer. Why would they want to have a computer in home? So they thought it's a small business. So they allowed and even encouraged people to reverse engineer their thing. So there was a company named Compaq. The name which I'm saying, it won't make any sense to you because that names have disappeared. The high-tech business is ruthless. It will give you money, and you can earn money, and it would throw you out like anything in no time, and people would forget about you. So IBM misread. They got out of PC business, and then PC and laptop became so important that, in fact, they were in Lenovo brand. IBM had the Lenovo brand, which now is, again, they sold it to a Chinese company. So Lenovo laptop, which are mainly used in all the offices, you will find that, Lenovo now is a Chinese company. In fact, Lenovo was a very good and very reliable brand. So that means IBM misread. Now, thankfully, they have reinvented themselves as a services company. So now IBM, which was considered as a totally hardware company, is now into services. And, they are into cloud, and they are into, setting up infrastructure for you. So they had to change their role. And there are companies which were not able to change their role. So there are companies like Sun. I told you that, I got Sun machine to work with. So it is like equivalent to having a Mac machine, which is like, top of the line to work with. And then there were DEC, or Digital Electronic Corporation. So DEC computers. Then there was HP. And then there was like, the best computer for graphics was Silicon Graphics. These were all known as workstations. Now you may not have even heard of these names. And why? Because they did not figure out the changing times. They took a long time to understand that technology is shifting, and they stuck to their own business. They think, okay, let me make, workstation is the future. That's where we concentrated. Now the whole idea of workstation is gone. Now any computer can be used by a gamer or a person who's a programmer or a scientist. So they lost out. So during this thing, I will refer to many things where companies who are working in the business of computer architecture or computer science in general, they did not recognize the times are changing. One very successful company, thanks to Satya Nadella, is Microsoft, which figured out that the times are changing, and that, they jumped out from just concentrating on Windows and concentrating on, say, Office products. Now, the main business is coming from cloud. So Microsoft Azure Cloud. So that's the major thing. That's where the major revenues are coming. So the companies have to reinvent themselves, otherwise they are gone. Intel is facing same trouble, and this is what it is showing all about. But Intel had got the market totally covered in these two regions, like desktop, laptop, server, and high performance computing was all Intel till 10 years ago. And ARM was known as like embedded system. So small embedded system, small toasters, washing machine, and phones at that time were used by ARM. I mean, they were supplied processors using ARM technology. In fact, there are many companies which make ARM compliant processor. So Qualcomm, Renaissance, Samsung, this TI, they all make ARM-based, ARM-compliant processor. Why? Because ARM has a licensing model. But it was limited to embedded system. And by the way, the phone processor till 10 years ago was known as embedded processor. If you had asked someone, if you had asked your dad in 2005 or 7 or 10, that how fast is your phone? Then he would have looked back at you and said, what do you mean? Right? Because, of course, there were processors in the phone at that time, but no one actually knew. I mean, you must have seen the Nokia 3110 or 5110 phones. They're still pretty useful, reliable. And actually, all it would do is like you can make phone calls and get SMSs. And if you're lucky, then 1 square inch screen, you can watch small movies or something. So it used to have embedded processor inside. So that was cornered by ARM. But the game changer was this mobile internet devices or mid devices, of which smartphone is one of the biggest thing. And that changed the fortune. Intel thought that, okay, it's like a small embedded system thing. We don't want to spend our energy in it. They are very comfortable. We have cornered this market. And this is like a big company like this don't work on margins that, ARM makes 2 cents or 3 cents per sale of one processor, not more than that. So they said, why should we worry about such junk amount of money? So ARM slowly crept into this smartphone, and suddenly there was an explosion in the smartphone market. And Intel then started coming with Atom processor, and they supported Lava phones in India. I don't know how many of you have even heard or seen or owned a Lava phone, but Lava had Intel Atom processor. It was working fine, but problem, power consumption. The battery would go dead in 6 hours. So Lava phone failed. So basically the chips which they are making, Atom or anything, is now not used. And now desktop laptop server segment is also under attack from ARM architecture. You must have heard of M1 chip, which is produced by Apple and which of course uses ARM architecture, is now the top performer. And many other companies like Qualcomm and others are coming for desktop processors which are based on ARM. So once again, this is the battle. I think we have spent enough time and the time is almost up. I hope you enjoyed this lecture. If you have any question, please let me know. And in the next section, we'll start with ARM architecture. Okay, any question? Okay, so I'll stop recording this.